So we're finishing up 3-7 today. Okay. So for this first little bit, just kind of watch with me. Just talking about some things building up to what we're adding on to today. So if we were solving an exponential equation, we know that we want to first isolate the base, get it completely alone. Nothing added to it, nothing multiplied to it. So what would we do? Add 1 to both sides of the equation. So we have 3 times 3 raised to the 7n is equal to 82. And then we would completely isolate the base. This next step's really important. What would we do? Good. Divide both sides by 3. So then our 3's divide out. All right, so we have 3 raised to the 7n is equal to, and you do 82 divided by 3. So let's just leave it as 82 thirds because it's a decimal. So we're going to leave it as 82 thirds. And then we would undo base 3 by taking the inverse of base 3, which is what? Good. Log to the base 3. Log to the base 3. So then log to the base 3 and base 3 cancel out. That's what inverses do. So we have 7n is equal to log to the base 3 of 82 thirds. Yeah? And then we would divide both sides by 7. Now n is completely alone. You type it into your calculator. Oh, but to be able to type it into our calculator, up here we would have needed to use the change of base formula, which we can still do, right? To type this in, change of base formula. So I probably would have done that first if I would have been paying attention. So we would have changed this first to be log of 82 over, 82 thirds, right? Divided by log of 3, and that's over 7. Did everybody follow that? Sorry. I should have probably done that before I divided 7, so I didn't confuse anybody. So then you type it in, log of 82 divided by 3, divided by log of 3, divided by 7. And you get 0.430.43. So n is equal to 0.43016. So that's how we solved an exponential. Then, number 11, we were solving log equations as well. So I want to make sure that we're good with this one. How many of you actually try this one by yourself? If you haven't already, if you have me come check your answer. You should have done it last night as homework. If not, so you're lucky. So looking at this one, we have log to the base 9 of x squared minus 7 minus log to the base 9 of 2 is equal to 1. First things first, when solving logs, we have to combine this into one logarithm, right? Okay, so we'll use properties of logs. So we're going to have log to the base 9, and we have x squared minus 7, right? X squared minus 7, and then this is subtract. When you divide, when you subtract, okay, so divided by 2. Does everybody understand how the left side is now this? Same thing, this is pulling it together using properties of logs. And that's equal to 1. Okay. Alright, so then from there, we've got to undo log to the base 9. How do we undo that?
Base 9.
Good, base 9 of both sides of the equation. So then base 9 and log to the base 9 cancel out, leaving us with x squared minus 7 over 2, sorry, I was making sure I was recording, is equal to 9 to the first power, right? So then from there we have x squared minus 7 over 2 is equal to 9. Then we would multiply both sides by 2. Now, on the left side, do I multiply the 2 through? No. What happened with it? The 2's went away, right? Don't double dip. Okay, so we are left with x squared minus 7 is equal to 18. Then we'll solve for x piece by piece, algebraically add 7 to both sides of the equation. X squared is equal to 25. Then we take the square root of both sides. So x is equal to plus n minus 5. The square root is plus and minus. Hey, Scott, am I not amusing you? Is this not fun for you? Because I'm thinking I'm dang fun up here. So you need to be listening, okay? All right, so we have x is equal to plus and minus 5. How many of you forgot the minus? It's okay. Yeah, we all do. I do it too. We just got to be really careful because truly both answers are correct, okay? Now here's the thing. Okay, actually, now I want you to try number 26. Ready, set, go. Before we get into here's the thing. So ready, set, go. Do number 26. All right, so first things first, we've got to pull this together into one log. Guys, let's go. So we've got to pull this together using properties of logs into one log. So the good thing is, I was seeing some good things. You were grabbing the 2 and bringing it up into the exponent. Now, wasn't that 2 in front of log of 3x? So wasn't that 3x technically? Okay, so we've got to be really careful. So we have log of parentheses 3x squared, and then we have minus log of 9 is equal to 1. So then from there, now we will pull it together using properties of logs. So we have log of 3x squared, and since it's subtract, we divide. Divided by 9 is equal to 1. Then from there, to undo the log, we've got to take the right base. What base is technically down here? 10. So we'll take base 10 of both sides. So then log of base 10 and base 10 cancel out. So we have 3x squared divided by 9 is equal to 10 to the first power, which is 10. Are we all following? So Jaden, are you seeing where you made your error right now? Not quite yet. You are? Okay. So then from here, we're going to solve for x algebraically. We're going to do what? Good. Multiply both sides by 9. Now I'm going to ask you, Dylan, do we multiply 9 in? No, we would divide it out. It's gone on the left. Very good. So we have 3x squared is equal to 90. And then from there, a couple different ways to do this one. Well, first of all, I'm just going to say, okay, I know 3x squared is 9. 3 squared is 9, x squared, which is equal to 90. And then algebraically solve for x. Divide by 9. X squared is equal to 10 square root. So x is equal to plus and minus the square root of 10. What? Oh, nope, you did awesome. All right. Questions on that one? You do have questions? Okay. Yeah, let's hear it.
Well, technically, I think we just, when we had our 3x squared, we can distribute it, and then we just straight divide by 3.
Okay, gotcha. Yeah, that would be a common error. So the only reason we would be really careful with that, so you understand, is it was log of 3 and x, right?
Yeah.
So the 2 in front would go up to whatever's inside here, whatever the log is of, which is both things. Yeah, good question. Yeah. All right. Okay, so now everybody listen, this is very important. So now I'm doing a little aside, like, okay, now besides the point, okay? So besides the fact, so when solving other types of equations, we've been checking our answers, right? Guys, there's way too much talking going on. What's the deal? Scott, I need you to come right up here so I can babysit you. Thanks. I'll see you up here in about 5 seconds. All right, so when solving other types of equations, we've always been checking our answers, right? By plugging our answers back in. All right, now we have to do this with logs because we cannot, right there's perfect. I can just see you in those beautiful smiling face. Okay, we need to do this with logs as well because we can't have a negative number in a log. This is not good, okay? So if you type this into your calculator, it's going to say error. You cannot have a negative number in a log. Does everybody understand that? So this would be considered an extraneous solution. Okay, so if we have a negative in a logarithm, it will be an error. That means it's an extraneous solution, okay? So everybody, we've got to go back to our answers and check to make sure that we don't have any negatives. So let's look at number 11. What did we get as an answer? X is equal to plus and minus 5, okay? So x is equal to positive 5 and x is equal to negative 5. Now we might keep both answers, we might throw one out. We've got to check it. So just look to see if there's any negatives. If we plug in a positive 5, 5 squared, right? Everybody, is 25 minus 7, is that a negative? No. If we plug in -5, isn't -5 squared still positive 25? Yes. So that would still not be a negative in the log. Do you understand what I'm checking? So we would keep both answers. Does that make sense, everybody? Okay. So let's see, what other one? Number 26, I think we got a negative answer too. Yeah, we did. So on number 26, we got x is equal to plus and minus the square root of 10. So really, we got x is equal to positive square roots of 10, x is equal to negative square roots of 10. Let's look if we plugged it back in, and this is where I'm going to look. If we plugged it back in, would we have a negative? So if we plug in positive square roots of 10, 3 times that squared is going to be positive, right? What if we plug in negative square roots of 10? It's squared, so it won't still be positive. So we keep both answers. But there will be answers today that we have to throw out. Okay. All right. Does everybody understand on where to check? Okay. All right. So look at number 6 with me. How many of you are not? Yeah, number 6. Yeah. Number 6. So we did this one together the other day. So let's look at it and see if we would need to throw out one of the answers. We got plus and minus 8. So looking back here, if we plug in positive 8, we're good. If we plug in negative 8, aren't we still good? So we did keep both answers. All right, so now we're moving on to what we're learning today. So I'm just saying, go back through, check your answers, make sure that you're not plugging in any negatives. But really, today we're going to be throwing out some when we get to what we're doing today. So now we're going to be dealing with today a special type of exponential function. It's e to the x. So we have seen e to the x in here. We've graphed it somewhat. So looking at this, y is equal to e to the x. Just remember that e is just a number. A lot of people see the e and they think that it's a variable, but it's just a number. If you take your calculator and you want to know what e is, you can take your calculator and do e, so you'll do second ln, so e raised to the first power, because that's just e, right? Anything to the first power is just itself. So e is just approximately 2.7. So e is just a number. So if we had a 3 there, if we had a 3, y is equal to 3 to the x, this looks no different than what we've been solving, right? So technically e is 2.7 to the x. Do you see how they're the exact same thing? It's just we're going to use e, okay? Now the inverse of e is ln, which is natural log. It's a log, but it's a special type of logarithm. It's the natural logarithm. So e to the x and ln are inverses of each other. Just like exponentials and logs are inverses of each other, this special exponential has a special inverse, and it's the ln, natural log. Now your calculator has an ln button too, the natural log button, so we're going to be using that. Now understand something, properties of regular logarithms hold true also for natural logarithms. So it's going to work the same exact way. It's just we're going to be undoing them a little bit different. So the best way to understand how this works is just by example. So let's do number 14 together. All right, number 14. So you should all be taking advantage of the time. No one should be sitting without a pencil because I'm doing problems from your worksheet. So everybody's writing, paying attention. Here we go. So we have negative 4 e to the x minus 6 is equal to negative 85.7. So the first thing is if you were to see this on an ACT or end of level, they're just going to say solve. You're going to have to look at this and say, oh, that's just an exponential function. I know how to how to solve exponential functions. We first isolate the base. So let's isolate the base. What is the base? The base is e, so let's get it all by itself. What am I going to do? Plus 4? Good. Divide by what? Good. Divide both sides by negative 4. So divide both sides by negative 4. So left on the left side of the equation is e raised to the x minus 6, and that's equal to, just take your calculator, do that. You'll do negative 85.7 divided by negative 4. You get 21.425. Does everybody understand that? Now, this is the special type of exponential function. Log does not undo it, but the natural log does. So now that we've isolated the base, normally we would take the log of the base. But we can't take the log of e. What we can do, though, is e's inverse is ln. So we're going to take the ln of both sides of the equation. Then ln and e cancel out. They're inverses of each other, leaving us with x minus 6 on the left. On the right, we have ln of 21.425. Just like we took the log of both sides. Does that make sense? It's just natural log, okay? Very good. And then from there, we'll solve for x algebraically piece by piece. To get x alone, now what would we do? Good. Add 6 to both sides of the equation. So then our plus 6 and minus 6 are gone, inverses, and we have x is equal to the ln of 21.425, close your parentheses, plus 6, and then you'll just use your calculator. Type it in, but make sure you type in ln. So log key, right below it's ln. So you'll type in ln of 21.425 plus 6, and you get 9.06. 9.06. All right. So x is equal to 9.06. Oh yeah, so we're going, good point. Thanks for catching that. So 10,000, so we're gonna go 4 decimal places. So we'll do 4, 6. Now guys, this is seriously this test that's coming up next week, very quickly here. You should be able to get every single problem correct and know you've got it correct. You should know your score before you hand it in, because you'll check all your answers. So let's take our calculator and check our answer. So back to the original problem here. You'll type in -4, and then you'll go second ln, so it says e. So in your calculator, hit the second key, then go to ln. So that would be e. So we're doing -4 e raised to the, and then you'll do second answer. So you can put back in that full decimal. You've got to put in the full decimal. So our calculator has the full decimal there. Does everybody see what I'm doing? The full decimal. So you'll hit the second key, which is up at the top key, and then answer is the minus sign down at the bottom. Does everybody got that? Or do I need to pull up my calculator? On here. Are we all good? Are you practicing checking, all of you? Okay, so then you'll do -6, right? In the exponent, close your parentheses, and you get -85.7. Is that what it is? Yes? So we know we for sure got it right. Because like I said, guys, a lot of these answers, you're like, that's a really odd answer. Did I get it right? Well, now you can know. Does that make sense? Okay, let's do another one. Number 16, here we go. So once again, on the test, on the end of level, on an ACT, it'll say solve. Simply solve. You have to know, oh, this is an exponential function. I've got to isolate the base and then get rid of the base correctly. So first things first, we would add 3 to both sides of the equation. So we have e raised to the -8x is equal to... Are we all following me? And then you tell me, what undoes e? ln of both sides of the equation. So then ln cancels out with e. We have -8x is equal to the ln of 49. And then we would divide both sides by -8. So x is equal to ln of 49 divided by -8. So you'll type it in, ln of 49 divided by -8, and you'll get x is equal to -0.4865. Then I always go back and check it by plugging it back into the original equation, but using the full decimal. You must use the full decimal. So once again, do you all feel comfortable doing that?
Yeah.
Okay, so I'm going to give you a second to practice 14 through 18. Ready, set, go. Okay, so now let's apply our knowledge backwards. So now we're given an ln equation, we have to be able to solve it. Now once again, on an ACT, on my test, on an end of level, they'll simply say to you, solve the equation. So you'll have to know, looking at this, okay, I have an ln equation that's similar to a log. I've got to use properties of logs to pull this into one ln, one log. So on the left side here, we're going to pull it into one ln. So using properties of logs. So we have the ln of x plus 7, and then when you multiply, you add. So when you add, you multiply. So times by x. Is everybody following? So that's equal to the ln of 60. Everybody sees how I pulled it into one ln. Okay, so then from there, we need to undo ln. What undoes ln? E. Good. So we take the inverse of both sides. E. So then E and ln undo each other. We're left with x plus 7 in parentheses times x, which is equal to E and ln cancel out, is equal to 60. Now we're going to solve for x. So we're going to distribute our x through. So we'll have x squared plus 7x is equal to 60. So my question is for you from here, and this is a really good one because it's testing your knowledge in being able to solve ln's. It's testing your knowledge in solving quadratics. Can we just simply get x alone, take square root? No, right? We have a bx, so we can't. All right, to solve a quadratic, there's two different ways. Solve by factoring, if it's factorable, or solve by the quadratic formula. But before you can do that, you have to have it set equal to what? 0. So to get this set equal to 0, I'm going to subtract both sides by 60. So I have x squared plus 7x minus 60 is equal to 0. Now, to be honest, I'm going to just be straight up with you. I'm going to make sure I give you one on the test that you have to solve by factoring or the quadratic formula. I'm going to give you one that factors. Isn't factoring easier now that we know how quick factoring? Yes. There's a lot less room for error. So I'm telling you, they factor if you can solve them by a quadratic. Okay. So I'm going to factor this one. We're going to do what multiplies to be, what multiplies to be a times c and adds up to be b. What's a times c? 1 times, so what multiplies to be negative 60 and adds up to be 7, right? Is everybody following me? So then from there, you'll list out factors of 60. Can anyone tell me the factors that multiply to be 60? 1 times 60, 2 times 30. 12 and 5. Okay, so 12 times 5. Okay, let's look at these ones. Or could any of them add up to be 7? 160, no. 2 and 30, no. These? They could add up to be positive 7. Which one would the negative need to be with? Now check it. Does it work over here? And it works over here. 12 plus negative 5. So check. So our factors are positive 12 and negative 5, right? So we know we can quick factor because our a value is positive 1. So we can just quick factor this. So this is going to factor to be x plus 12, since it was positive 12, times x minus 5, since it was negative 5. Now that we've factored it, and they're linear factors, degree 1, we can set each of them equal to 0 and solve. So we'll set x minus 5 equal to 0, and we'll solve. Subtract 12. X is equal to negative 12. And then add 5. X is equal to 5. There's our two answers. Now we need to check for extraneous solutions. If we have a negative, we need to check to see if we plug it in, we have a negative. So we scroll back up, look at our original problem. If we plug in a negative 12, so we have x is equal to negative 12 and x is equal to 5. We don't need to check 5, it's good, but negative 12. If we plug in negative 12, will it be a negative? Right here. Yep, so we can't have it. If we plug in negative 12 right here, it would be negative. So we throw that answer out. That's an extraneous solution. Okay. All right. Do I need to do it? Oh, wait. I'm just going to do one more really quick. Last one. Number 22. Number 22. ln of negative 3x minus ln of 9 is equal to 3. First things first, combine these using properties of logs. So I ask you to solve, you'll combine it using properties of logs. So we're going to have the ln of negative 3x, then what? Good, divided by 9. Because we are subtracting, we divide. So divided by 9, that's equal to 3. Now this one's very important. Everybody stay with me, because I'm doing this one for a reason. How do we undo ln? We take the e of both sides. ln and e cancel out. We have negative 3x over 9 is equal to e to the third power. This is the answer that's acceptable. I don't want you to calculate e to the third. On an ACT, they wouldn't. They'd leave the answer as e to the third. Leave it as e to the third. Does everybody understand that? Now just algebraically solve for x. So I'm going to multiply both sides by 9. So we have negative 3x is equal to 9e to the third. I'm going to push you to put the 9 in front. You guys all can recognize that that looks better. Divide both sides by negative 3, right? So then what we would have is x is equal to, our negative 3's cancel out. We have x is equal to, what's 9 divided by negative 3? Negative 3, good. So we have negative 3 e to the third. This would be the appropriate answer for that. We would not calculate it. If we have an e, this is how they'd want your answer. Are we all okay with that? Okay, yes. So e is just a number, right? Oh, sorry, I see what you're saying. You could actually calculate that, and you would get a big long decimal and then just plug it back in. So that's fine, but I just, for your answer, for me, I want this answer. Yeah, good question. All right, finish the worksheet. Ready, set, go.